Questions 11 through 20 on the 2018 Grade 10 Cayley Math Contest. A large square has side length 4. It is divided into 4 identical trapezoids, and a small square is shown. The small square has a side length of 4. What is the area of the trapezoid? A few ways of doing this question. I think the simplest way is to understand that the full square is going to be 4 by 4. And if you subtract from that the small square, which is 1 by 1, you will get the area of the 4 trapezoids. So to get one trapezoid, you just divide by 4. So let's see what this gives me. 16 minus 1 over 4, which is 15 over 4. And I think that's the simplest way. There's other ways, but hey, why get unnecessarily complicated? So number 11, the answer is D. In an unusual country, there are 3 kinds of coins: X's, Y's, and Z's. X's, Y's, and Z's. In this country, the value of 2 X's equals the value of 2 Y's, and the value of 1 Z equals the value of 16 X's. The value of 1 Z equals the value of how many Y's? In Canada, this letter is pronounced Z. In America and many other parts of the world, it's pronounced Z. So that's in case you're watching outside of Canada and you're not sure what is a Z, it's the letter Z. Okay, so let's move forward here with this question. So from the question stem, 2E is equal to 29W. And they also told me that Z is equal to 16E. So I guess I can substitute here. Z is equal to 16E, which is 2 times 8E, or 8 times 2E. Probably better to write it that way, like that. And then 2E is 29W, so 29W. So 8 times 29 is 232. And therefore, Z is equal to 232W, and that is what they're looking for. So number 12, the answer is C. The number of integer values of x for which 3 over x plus 1 is an integer is. Well, let's plug away here, and let's see what we get. So we got a number line, and let's see here. We got 0, 1, 2, 3, 4, 5. I don't think we will need to go larger than 5. Negative 1, negative 2, negative 3, negative 4, negative 5. I think this should be good enough. For each of these, let's see what happens to the value of 3 over x plus 1. Let's start with 0. When it's 0, it will be 3. When it's 1, it will be 3 over 4. When it's 2, it will be 1. When it's 3, it will be 3 over 4, 3 over 5, 3 over 6. As you can see, as it's going that way, it'll never be an integer ever again. It'll be a fraction. So let's go to negative 1. Negative 1 would make it undefined, actually. So that doesn't work. Negative 2 makes it negative 1. Negative 3 would make it 3 over negative 2. Negative 4 would make it negative 1. And negative 5 would make it 3 over negative 4. So, and then as we go that way, it'll never be an integer. So the only time it was an integer is here, 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 and here, and that was for values of negative 4, negative 2, 0, and 2. So 4 values, 1, 2, 3, 4. So number 13, the answer is A. Including the endpoints, how many points on the line segment joining negative 9, negative 2 to 6, 8 have coordinates that are both integers? Well, I think finding the equation of the line will be helpful. So it's going to be of the form y equals mx plus b. Substitute in 2 points, and let's get the equation. So from the first one, we get negative 2 is equal to negative 9m plus b. From the second point, I get 8 is equal to 6m plus b. Okay, well, let's see here. If I multiply this guy by 2 and then add to it the second equation multiplied by 3, I think that will help. And when I do that, I get negative 4 plus 24, and on this side I get negative 18m plus 2b plus 18m plus 3b. So that means 20 is equal to 5b, and therefore b is equal to 4. Substitute b back in either of those, and when you do, you get a value of m of 2 over 3. So my equation is y is equal to 2 over 3x plus 4. And we want integer values for this. Okay, I don't think that should be a problem. Basically, let's see what kind of numbers we get. Let's make a tiny little table. All right, so we are starting at negative 9 for x, and that one they already told you. And from here, that basically tells me that in order for y to be an integer, x must be divisible by 3. So if it's negative 9, it can also be negative 6, negative 3, 0, 3, and then we'll go up to 6, because 6 would bring me up to the other endpoint. And the values from y, those are easy to figure out. 0, 2, 4, 6, and 8. So how many did I get? 1, 2, 3, 4, 5, 6. 6 points on that line between those two endpoints, including the endpoints that are both integers. So number 14, the answer is E. In the diagram, triangle PQS is equilateral. Also, triangle PQR and PSR are isosceles with PQ equal PR equals PS. Angle RPQ equals angle RPS. The measure of QRS is. Well, it's equilateral, so this is 60, this is 60. And this is also an isosceles triangle, so this angle will be x and this angle will be x, this guy and this guy. And because of the other triangle being pretty much the same thing, it's also isosceles with the same dimensions. This angle in here will be x, and this angle in here is also x. So the full triangle, the big one, the whole all the way around, it looks like 2x at the top plus x plus 60 plus x plus 60 is the sum of the angles, and that of course has to equal 180. So let's see, we got 1, 2, 3, 4, 4x plus 120 is equal to 180, and that means 4x is equal to 60, x is equal to 15. So what do they want? The measure of QRS. QRS is this angle right there. So angle QRS is 2x, x is 15, so that's 30. So number 15, the answer is A. A ladder has 5 rungs. Elizabeth can climb up by 1 or 2 rungs at a time. How many different ways can she climb up to the 5th rung of the ladder? This question is the equivalent of this equation. 1 times x plus 2 times y is equal to 5. Because you can reach the top rung, which is 5 steps basically, with some combination of 1 or 2 rungs, I guess. So we want integer solutions. And very quickly you will realize that the only ones are 5 and 0, 3 and 1, and 1 and 2. So I say, okay, well there's 3. That's the answer. But 3 is obviously not one of the answer choices. Then why is that? Because each of these perhaps can have different permutations. So let's start with the first one, 5, 0. The only way to do that is 5, 1 steps. That's the only way. So that only has one way. But how about 3, 1? 3, 1, I think that's going to be done in a few ways. You can have 1, 1, 1, and then a 2-step. Or you can put the 2-step here, or the 2-step here, or the very first step could be two rungs. So there's 4 ways of doing that. And then the 1, 2 combination of 1, 1 step and 2 steps, that can be either 1, 2, 2, 2, 1, 2, or 2, 2, 1. So how many did I create? 1, 2, 3, 4, 5, 6, 7, 8 ways. And therefore number 16, the answer is E. If x minus y over x plus y is 5, then 2x plus 3y over 3x minus 2y equals x minus y, x plus y is equal to 5. So cross multiply and we get x minus y is equal to 5x plus 5y. And let's collect like terms. 4x would be equal to 6y. So 3 over 2y is equal to x. And don't forget the negative. Almost forgot the negative there. All right, so now let's turn our attention to this guy right here. 2x plus 3y over 3x minus 2y. Well, I can substitute the fact that x is equal to minus 3 over 2y. So that would be 2 times minus 3 over 2y plus 3y. And then on the bottom, 3 times minus 3 over 2y minus 2y. So the top becomes minus 3y plus 3y. The bottom becomes minus 9 over 2y minus 2y. The top is 0. Okay, well, that's it. Number 17, the answer is B. A quadrilateral is bound by the lines x equals 0, x equals 4, y equals x minus 2, and y equals x plus 3. The area of the quadrilateral is. We will need a diagram, so let's draw a diagram. And it doesn't have to be a work of art, but let's just draw these. So x equals 0 is basically just the y-axis. So this is the y-axis, but it's also x equals 0. X equals 4, well, we can call this 4, and then a line right through it would be x equals 4. So let's draw a line right through it. And then y is equal to x minus 2. I can just plot 2 points really quickly. When x is 0, y is negative 2. And then when x is 2, y is 0. So those 2 points, that would connect to form that equation. And this one, y is equal to x plus 3. Again, plot 2 points really quickly. When x is 0, y is going to be 3. So approximately here. And when x is negative 3, which is about here, y will be 0. So connect those two. So there we go. The quadrilateral obviously is this guy right here. And we have to figure out the area of that. Okay, area of a quadrilateral is basically base times height. So I just have to figure out some distances. The first distance is going to be the base, and that should be relatively simple since we know those points. This point right here, that one is 4 and 2. And this point right here, well, that is 0 and negative 2. So using the distance formula, we can easily figure out that distance. So that's a base. 4 minus 0 squared plus 2 minus 2 squared, and the square root. So that's what, 16 plus 16. So that's 4 root 2. Yeah, root 32 basically. Okay, well, let's keep going here. Now we have to find the height. The height is not as simple. We have to do a little bit of more math here. So the height's going to be the perpendicular distance from any point down to the base like that, where that's a right angle. So we're going to need the equation of that line, this line right here. Shouldn't be a problem. Y is equal to mx plus b. Now this line is perpendicular to this line, right? And this line here has, what is it? Y equals x minus 2. Yeah, so that has a slope of 1. So the line that's perpendicular has a negative reciprocal as a slope, which would be negative 1. So immediately we know that m is negative 1. And then b I can get by substituting any point. So let's just substitute that point, which would be, what's that point? 0 and 3, because that's on this line right here. So when y is 0, we have b. So b is 3. Okay, so that equation is y is equal to minus x plus 3. All right. So now we have to figure out the intersection of that line with this line. That line was minus x plus 3, and the other line is x minus 2. So minus x plus 3 is equal to x minus 2, so that means 5 is equal to 2x, and therefore x is equal to 2.5, because 5 divided by 2. And substitute that into either of these, and when you do, y would be a half, 0.5. So that means this point right here is 2.5 and 0.5. So now we can easily figure out h. That is this distance right here, that red line. So h is going to be 2.5 minus 0 all squared plus 0.5 minus 3 all squared. And that's going to be under the square root sign, so that's going to be 2.5 squared plus 2.5 squared. So that is 2 times 2.5 squared, so 5 over 2 squared like this under the square root. So it's really 25 over 2 square root, which is 5 over root 2. Okay, so now we come back here to the very beginning. Base times height. The base was right here, 4 root 2, and then the height we just figured out was 5 over root 2. And therefore the root 2's cancel, and I just get 4 times 5, which is 20. And therefore number 18, the answer is E. In the diagram, 2 circles overlap. The area of the overlap region is 3 over 5 of the area of the small circle and 6 over 25 of the area of the large circle. The ratio of the area of the small circle to the area of the large circle is. Well, let's make some regions. Let's call this one A, let's call this one B, and let's call this one C. So based entirely on the question, A is equal to 3/5 of A plus B of the small circle. And A is equal to 6 over 25 of the big circle, which would be A plus C. So from this, if we just isolate for A plus B, it will be, if you cross multiply, 5A over 3. And from this, if you isolate for A plus C, it would be 25A over 6. So what do they want? The ratio of the area of the small circle to the area of the large circle. So the small circle over the large circle, like that. And that's going to be just 5A over 3 over 25A over 6. So 5A over 3, invert and multiply, 6 over 25A. The A's cancel, and we get 30 over 75, which would reduce to 2 over 5. Yeah, that's it. Therefore, number 19, the answer is D. Abigail chooses an integer at random from the set 2, 4, 6, 8, 10. Bill chooses an integer at random from the set 2, 4, 6, 8, 10. Charlie chooses an integer at random from the set 2, 4, 6, 8, 10. What is the probability that the product of their 3 integers is not a power of 2? Well, the probability will be some numerator over the denominator. The denominator is the total. So for Abigail, Bill, and Charlie, Abigail has 5 numbers to choose from, Bill 5 numbers, and Charlie 5 numbers. So you multiply to get the total, which is 125. So the total is 125. Now, we want the probability that the product of their 3 integers is not a power of 2. I think it's easier to count the powers of 2, and then that I will subtract from 125 to figure out the ones that are not a power of 2. So what I'm really looking for is this number right here. Okay, so let's do that. What are the powers of 2, for example? Powers of 2, 2, 4, 6, 8, 16, 32, 64, 128, 512, 256, sorry, and 512. And I think that's all we need to go up to, because the largest possible number we could create is if all of them chose the 10, and that's 1,000. So no product could ever go over 1,000, because the next one would be 1024, and we don't need to include that. So these are the only ones we need to worry about. There's quite a few of them, so we have to go through these one at a time. Okay, no problem. So let's make a little table here. Well, here we go. A, B, C for Abigail, Bill, and Charlie. Well, let's talk about this one at a time with regard to powers of 2. The first one, 2. Is there any way to get a product of 2? And that's impossible, because the smallest product you could ever get is 2, 2, and 2, which is 8. So 2 is not going to happen. Same reason 4 is not going to happen. And the only one that could happen in terms of the very first one is 8. So how do I get 8? The only way is to have 2, 2, 2. So that is the product, 8. Okay, we're done with 8. How about the next one, 16? How do I get 16? The only way is to have 2, 2, and 4, but that can be written as 2, 4, 2 or 4, 2, 2. So those are the ways of getting 16. Now let's talk about 32. How do we get 32? 2, 2, and 8 would do it, but we can also have it as 2, 8, 2 or 8, 2, 2. Another way is 2, 4, 4. 2, 4, 4 would also give you that, but you can have it as 4, 2, 4 or 4, 4, 2. So these, how many? 6 are the ones where the product is 32. Now let's move to 64. How do we get 64? The only way is 2, 4, 8. But that has 6 iterations as follows. 4, 2, 8, 4, 8, 2, 8, 2, 4, and 8, 4, 2. So that took care of the 64s. 128. I think the only way is 288. I think so. 288. So the 2 can go here or here. So 8, 8, 8, 8. But I think 128 can also be made with 448. 448 would also do it. Yeah, 16 times 8, right? So that would be 484, 844. Okay, that takes care of 128. And then the last one is 256. Actually, second last one. 8, 8, and 4. I think is the only way. So 8, 8, and 4, or 8, 4, 8, 4, 8, 8. That takes care of 256. And let's see here, 512, right? 512, there's only one way, 8, 8, 8. And I think that's it. Let me see, am I missing one? And it's always a good idea to double check. And when I double check, I am missing one. Aha. All the more reason to go back and double check. For 64, I forgot one. And it's a pretty obvious one that I forgot, 444. Okay. Well, there you go. I got them all. So let's count them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27. 27 is this number, which was the number I was looking for. All right, so that means the probability 125 minus 27 is 98. The denominator is 125, and that's the answer. So it's an interesting little question. Number 20, the answer would be C.